I know that was difficult, so let us see in a different way. Let us see in a different way that you know. So let us take this 1 upon 4 pi epsilon naught as k. You know this is constant k, 1 upon 4 pi epsilon naught. So we started with Coulomb force. So what was Coulomb force? There is a constant. There were two charges Q1 and Q2 and the square of distance between them. So this was Coulomb force. That much you remember. What was electric field? Suppose if we remove this charge, this one charge, then due to one charge, what was there? There was only electric field. Due to one charge, there was electric field. This charge was gone. So that is what I have written here. E is equal to K. Q1 is equal to Q. That I have changed because there is not another charge, and the distance remains same. So what we said then when there is a second charge, only then there is a force. Otherwise there would be an electric field. So this much you know. So if we compare this, so there would be force only when there is another charge small q. There is force only when another charge small q is there. Let us say this q2 is small q. Now this formula you also know, that work done is force into distance. This formula also you know, that work done is force into distance, F into R. So this much also you know. And this work done itself will stored as potential energy. That also you know, that potential energy is simply the work done. If we do some work on any charge, this will store as potential energy. Similar to if we move this ball up, then there would be potential energy in this ball stored due to the work done. So till now good enough. Now what happened? So this potential is there. So potential is there, but problem with this potential energy is that it is charge dependent. It is charge dependent. You see, force is charge dependent. If charge is bigger, there would be more force. Hence, work needs to be done more and more potential energy. Again, if charge is more, there would be more force, more work done, more potential energy. So we need a quantity which is charge independent. So what we did, we divided this W simply by Q. So what is this simply remaining? W by Q. So W is delta U by Q, or we can write simply what was W? W is F R. F is, what is F? F is simply this QE. F is simply QE. F is simply QE. Okay. And this R and this Q. So Q and Q cancels out. V is equal to ER. ER. And in another way, V is equal to W, this QER, and Q cancels out. But how this cancels out? Because we are dividing it by charge. So V is simply ER. V is simply ER, or E is equal to V upon R. E is equal to simply V upon R. So in another way we understood that E is simply equal to V upon R, or V upon R, or V is equal to E R. So let me put it another way. Similar to work done is force into distance. Potential is equal to field into distance. So when we move against a force, then we have to do some work. When we move with a force r distance, there will be a work done. Similarly, moving a charge in electric field will create potential. So now it is much more simpler. When we move something with a force, that would be the work done. Similarly, moving any charge in an electric field is the potential. Now let us see again if we can understand it now better. So there are two surfaces. surface A and surface B. We have a point P on surface B. The potential on surface A is V. Here it is little bit higher, V plus delta V. The electric field in this outward direction. So that means charge must be here, only then it is going outward. And you can see that at each and every point this electric field is normal or perpendicular to the surface. Now what we are trying to do, we are moving unit positive charge. So positive charge Q, and that is also unit. So that means we have already divided by Q. That is, we have already divided by Q. So we are moving a unit positive charge from B to A. So and in that case, so how much distance we are moving? We are moving delta L distance. This work equals to the potential difference V minus B. So why they are saying this, that work done in this process is EDL? Why? Because work done, you know, force into distance. Okay, force is QE, distance is delta L, and Q is already 1. So Q is 1. So this is simply EDL. So here it is. Now this work done to equal potential difference. Why it is equal to potential difference? Because this work done will be stored as potential energy, and potential energy is simply if we want to convert this potential energy into volt, so we have what we have to do, we have to divide this by U by Q. Again Q is 1, so this is also difference between potential energies. So this potential will also be equal to potential difference. So potential difference between these surfaces is, so we are bringing to here, so that means VA is first, we are bringing from VB, so VB is here. So hence this work done must be equal to potential energy, which is also equal to potential. Why? Because we have taken charge to be 1 1. Why potential energy and potential are same? Because charge is unit. Why work done and this EDL is equal? Because here Q is 1. Again, why the potential energy and potential is equal? Because charge Q is equal to 1. In both the cases it is 1. So what has happened? So let us put together EDL from here. Now potential difference VA minus B. So VA is V minus VB minus V plus delta V. So there is a negative delta V. So same thing, if you see, I have shown you that V is equal to ER. See, V is equal to EDL. So since this difference is small, because distance moved is also very small, so that is very similar. V is equal to ER. If we divide, E is equal to minus delta V upon delta L. Now since delta V is negative, since this one is negative and we don't want negative quantities in our formula, what we do, we again put a negative sign outside and take the mod of this. So mod is again a value and we put this negative sign outside. So E is equal to minus del V upon del L, sorry, delta V upon delta L, and this is delta V upon delta L positive. So this is the your formula. Okay, so this is your formula here. So we thus arrive at two important conclusions concerning relation between electric field and potential. So two things. Electric field is in direction in which the potential decreases steepest. So electric field is in direction where potential decreases steepest, that means same direction. Its magnitude is given by the change in magnitude of potential per unit displacement. Same thing, change in potential per unit displacement normal to the equipotential surface, because we were moving normal to the equipotential surface. This was the equipotential surface. We were moving in this direction. So it is simply delta V by delta L.